Hello everyone, today in this video we'll be discussing the fifth module of data communication, and this module has three topics. First one is for wired lines, means using a wire, and second one is wireless, which is the Wi-Fi and all, and the third one is other connections like cellular telephony. Okay, and before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. The first topic is wired lines Ethernet. Ethernet is nothing but just a cable. Okay, and in this there are some protocols and the rules to be followed. Like first you have to select which type of protocol you want. Like LLC is the logical link control, which will have a single link, and MAC is the media access control. It will have a specific link for each device. Okay, it will provide the error and flow control, so the data is more secure in this one, and it's more expensive also. Okay, and Ethernet has been since a long time, so it has 4 generations. First one is standard, second is fast, and this one is GB, and this one is 10 GB. So let's discuss each one by one. In standard Ethernet, the data speed rate is 10 MB per second, but it's very unreliable and lack of synchronization. So sender may send some data, but it will not get any acknowledgement from the receiver if it has received or lost. Okay, and the data format will be as follows. The first one will be for the identification of a new data which is coming, and the destination source address, and the type of data, and the data here. And CRC is a cyclic redundancy check, which we learned in the third module for error detection. Okay, and this is the addressing format. We will have the 6 bytes here, or 48 bits, which will be divided into 6 parts. If we divide into binary here, the address will be as follows. And when we send the data, what actually happens is, if this is the data to be sent, the last bit which we sent here will be received by the receiver. Okay, and there are 3 types: unicast, which is from source to receiver; multicast is from one source to multiple receiver; and broadcast is from one source to multiple source. See, observe here carefully, it's from one source to multiple source, not for receiver. Okay, that is used for broadcast. Okay, and to implement the Ethernet, we will be using 2 topologies: bus topology and star topology. And to identify which address is unicast, multicast, or broadcast, we'll see the last bit. If it's 0, it's unicast; if it's 1, it's multicast; if all the bits are 1, it's broadcast. Okay, and it uses one persistent method. That means in the previous module where we learned, one persistent means the source keeps on checking the data channel. When it becomes free, at that time it will send the data. Okay, so it uses CSM CD technique. Okay, and the total time is the time taken to travel from one end to other end, also the time taken to send the sequence onto the channel. Okay, this is the total time taken, and the efficiency is defined as time taken by the station to send the data, and divided by how much time it occupied the medium. Okay, and the implementation is in 4 levels, depends on what how much distance is to be covered. Like if it's 500 meter, you will go with this one; if it's 185, you will go with this one, or 100 and 2000. Okay, so let's discuss each one by one. So before that, the data is sent in this way, which is encoded, and we use Manchester encoder, and the data is sent here, which is decoded further at the receiver end, and the data is received here. Okay, so let's discuss about the different implementations. The first one is 10 base 5 thick Ethernet. This means it uses coaxial cable. It can be used if you have to send the data maximum length of 500 meter, and it uses bus topology. Okay, and the second one is thin Ethernet. It uses a much thinner wire, but it's more flexible. Okay, it cannot exceed more than 185 meter, and it's less expensive. Okay, and the third one is twisted pair cable, twisted pair Ethernet. This you might have seen in your home, where you have a socket here which will be having many switches, and you will plug in the charges of different devices. Okay, this is the same thing. It cannot exceed 100 meter, and it uses star topology. Okay, and the last one is fiber Ethernet. It's very costly because it uses optical fibers to transmit the data, and it also uses star topology, but it can be extended to a large distance. Okay, like 2000 meter, maximum 2000 meter. Okay, so by using this, the 2 lines are connected, and this data transfer is more secure than the previous methods. Okay, if you want to make the data more secure, what we can do is bridging will provide the protection to the data layer, so that the data which is being sent is more secure. Okay, so this is the single level bridging, and second level bridging is the different domains will be there of computer, which will be bridged to a single transmission line, and those will be distributed to the receiver end. Okay, and that can be done by using switch also. We'll have different domains wherein we'll have computers. These are the same things, and we'll be having a switches here. Okay, so each one will be connected to one switch, and whichever data is to be sent to other device, first the domain will be identified, then data will be sent to the specific computer. Okay, so this is by using star topology. and it uses full duplex. Full duplex means two channels are there, one for sending and one for receiving, okay. And it uses point-to-point protocol, means it doesn't have any switch like that, means multiple devices connected to a single thing, and this is sending to multiple devices. It's not like that. There will be individual connection between each device, okay. That's the full duplex. And there is no need to use for CSM or CD, because since we are using two channels, the one will be for sending and one will be for receiving, so there is no point of collision here. So there is no need to use CSMA or CD method. Also it has flow and error control, okay, means full duplex will be more secure. So this was about the standard Ethernet. This is the fiber Ethernet. Here we can transfer up to 100 MB per second, and everything is same as the bit address, which is 48 bit, same frame format, and length is also same, okay. But the difference comes here, it can use full duplex also, half duplex also, and the star topology is used, and the new feature is auto negotiation. Auto negation means it allows the two devices to negotiate. If one has the high data transfer, other has low data transfer, they can negotiate to means this can negotiate with the higher one to send the data through it, okay. That can be possible. Auto negation, what it allows is the communication with devices having different capacities, okay. Like a device having the capacity of 10 MB per second can communicate with a device having 100 MB per second, okay. And also it due to this feature, the device can have multiple capabilities and also multiple hub capabilities, okay. So it can perform various operations which were not present in the standard one, and it will make the data transfer more efficient, okay. And coming to physical layer, it has, if you want to transfer the data between two stations, we will use point to point, else we will use star topology, okay. Point to point is as follows: one device to other device, and star topology is from one device, all the devices will be connected to a switch which will receive the data and send to the receiver. And there will be three levels of implementation for the fast Ethernet, which will depend on the length of the transfer, but the only difference comes here is these two are same, it just uses UTP here and it uses fiber cable here, okay. See, these both are same. This one will have the two pair twisted pair cable, but this one will have two pair of fiber cable, okay. Rest all things are same, both have good bandwidth performance, and data rate is 125 MB per second. But the difference comes here, these both use 2 wires, but this one use 4 wires, okay. So more data can be transferred in the last one. See here, it can transfer up to 100 MB per second, and here these are the first two ones, it just uses fiber cable, it uses the twisted cable, but the two lines only are there, right. The data is coming here from one line and going from another line, okay. Same thing for this one also, but in this one what we see is this is the encoder and decoder, and the data is coming from here and going from here, but in between that also there are two connections which are taken from the connection between decoder and encoder. This can also facilitate more faster data transfer, okay. The next one is the Gigabit Ethernet. In here we will have the data rate as 1 GB per second, and it is compatible with the standard or fast Ethernet. It uses the same things as 48 bit address, same for file format length and frame length, and also it supports auto negation, okay. But the difference comes in the transmission, it uses the full duplex or half duplex, okay. In full duplex it uses the same thing, which is two channels, and there is no collision because there is no CSM or CD. And in half duplex it is switch is replaced by a hub, okay. In before we were using switch, right, for connections. In this we'll be using hub, okay, and it's a one-way path, okay, because in half duplex only either you can send data at a time or receive the data at a time, okay. So and it has reduced slot time because it's 1 GB per second, so slot time is reduced. If you want to transfer more data, what we can do is increase the minimum frame length, okay. And the Gigabit is 8 times larger than the previous one, and it uses the concept of frame bursting. Frame bursting means adding of multiple frames into the same frame, okay. So multiple frames are sent together, okay. And the physical layer is same. We use two topologies, point to point for one to one, or we use star topology for the multiple device transmission, okay. That is the same thing, but the implementation is different according to the type of the data and the length of the data which you want to send, okay. And it's divided mainly into two parts, 2 wire and 4 wire implementation. This also we saw in the earlier, but the only rate is changed here and the encoding scheme is changed, okay. Before it was Manchester scheme, here it is NRZ scheme, okay. So in 2 wire we'll have like this, the 2 wires will be there, one for sending, one for receiving. But in the 4 wire what we'll have is parallel transmission. The encoder and decoder are connected by 4 wires here, and each one will have the connection to the media channel, okay. So this is the 4 wire channel. It's the same gigabit per second, but more transmission will happen because we are using 4 wires to transmit the data parallelly, okay. And the next one is 10 gigabit ethernet. In this we can send the data up to 10 GB per second. Other all things are same, but here the thing is it will be used for wider applications because the data rate is more, so it can be used for the worldwide connection. Okay, 10 gigabit per second. And the implementation is in the 4 levels according to the type of the data and the distance of the data transmission. Okay, topic of the module, which is wireless LANs. Till now we have learned about wired LANs. Okay, now we'll learn about wireless LANs. In wired LANs we used to use wires for connecting the host, and in wireless LANs we will use air as the medium. Okay, so the data will be transferred through air. Okay, due to by various waves like radio waves or other waves. Okay, and the host can move freely in the both wired and wireless medium, but host will be connected to the wires in the wired medium, and the wireless medium it can move anywhere. Okay, as long as there is network. Okay, and there are two types. First one is by using a switch, and second one is AP. This is used for the wire and for the wireless. Okay, this is the same thing, which is connected, all are connected here, but here it's wirelessly and here it is by wire. Okay, and the second thing which we need to know is while transmitting the data, signal losses can happen, and that is known as attenuation. And interference means two or more signals can come at the same channel, so that can cause the collision of the signals. And multipath propagation means in a same channel multiple signals are getting transferred, so that can cause some errors in the transmission, and the error is more in the wireless than in the wired. To have access control, what we need to have is a signal source which is sending the data is also able to receive the data. If it is not able to receive the data at that time, it cannot know if collision has happened. Okay, and in wireless it's very hard to send and receive the data at the same time. Okay, access control less in wireless than wired. Okay, and the last one is hidden station problem. A is here and B is here and C is here, and this is the range of B, and sometimes C will receive the signals from A through B. Okay, so that will cause the hidden station problem. 802.11, what we do is we have two types here, two types of services: basic service set and extended service set. In basic service set we have the various devices connected here in a private network. Okay, and like this many groups will be there, right? And to have a connection between those groups we'll be using AP. AP means access point. Okay, like this, like a hub which will connect the different groups here. Okay, if you connect it, it will be known as extended service set. We will have different groups connected to a wired LAN. Okay, through a single server. Sublayer, max sublayer, if you see in the graph, if you see in the diagram what it is, firstly we'll have a physical layer, then we'll have a data link layer, right? In the data link layer, the second one is there are two parts. First one is LLC and second one is MAC layer. And MAC layer is further divided into two parts, PCF and DCF. Now we had discussed in the previous topic about this one. Now we'll be discussing about PCF and DCF. Okay, what is DCF? DCF means distribution coordination function. Before that we need to understand why LANs cannot implement CSM and CD. It's for three reasons. A source has to send the signal and receive the signal also if the collision happens, but that is not possible in wireless networks. So the wireless LANs cannot implement CSM and CD for the first reason, which is collision detection cannot be acknowledged. Okay, and the second one is collision may not be detected because of hidden station problem. Okay, that we discussed earlier. And signal fading could happen because of wireless means it's a large distance, so the signal fading could happen. Okay, so these are three reasons why we cannot implement the CSMA CD for wireless LANs. Okay, and what is the working of DCF? In DCF we will have a source and a sender and the other devices here. What happens is source will send a request, RTS means request to send, to the destination. Destination checks the channel and sends clear to send. If it's clear to send, it acknowledges that, then it will send the data, and when the data is received completely, it will send the acknowledgement here. In between, the other devices inform that when the channel is busy, they will be informed that NAV is the network allocation vector. Means at this time the other devices cannot check if the channel is busy or not, because the data is getting transmitted. Okay, and after this gets over, the destination will send the acknowledgement, and when it sends the acknowledgement, they can check if the channel is free or not and transfer the data. Okay, PCF, which is point coordination function. Okay, it's an optional access method and it's time sensitive, and it's shorter than DCF, and it's also prioritized over DCF. Okay, and the main thing is they both function independently. So what happens is there are many devices here, all will send their signals. Okay, means at the time which they are busy, NAV they will send. Okay, so since many of the NAVs overlap at that time, the elongated time will be there for waiting for the other devices. To avoid that, we will be using a single time clock, which is called beacon frame. What it does is it sends repetitive frame which repeats continuously, and all the stations detect that. Okay, so all will be following one single frame which will be sending the signals, and by this all will be synchronized here. Okay, So if you look at the process of sending, so basically what happens is first there will be a selection process, and after the beacon frame means when the waiting time is over, selection will be there among the devices, and which device is selected, making a connection with that, and the data will be sent and acknowledgement will be given to the source. Okay. And fragmentation means larger chunks of data is prone to error, prone to more errors. So what we do is we will be dividing the large data into smaller chunks, so that they will be easy to handle and the error detection will be less also. Okay. And the frames which are being sent are in this format. It's not just the data, other things will also be there. Let's discuss each one by one. FC is the frame control. It defines some control information. D is the duration. It defines the duration of the data transmission. AD1 to AD3 and AD4 is the address lines. So each defines a different address. AD1 is the address of the next device. AD2 is the address of the previous device. AD3 is the address of the destination, means final destination, and AD4 is the address of the source. Okay. And there are 4 types. If it is from BS to DS, BS means basic service and DS means distributed service. Okay. So distributed service will have a group of computers and BS will have a single computer. If the address is of this type 0 to 0, that means base station basic service to basic service. Okay, means one device to another device the data is transmitted. If it is 0 1 means from 1 it is getting transmitted. 1 means DS. Okay, 1 means DS and 0 means BS. From distributed system means from a group of systems, and AP is used to transfer the data to a single device. 10 means from one device to group of devices. 11 means from a group of device to another group of device using 2 APs. Okay. Is the sequence control, which defines the sequence number, and the frame body has the data to be sent, and FCS is like CRC32. CRC is cyclic redundancy check, which we discussed in the module 3 about error detection. Okay. An expose station problem is, for example, consider that there are 3 stations here, A, B, C, and A wants to communicate with B, but C also wants to communicate with D. Both can do it independently, but it does not happen. Let's see why it does not happen. See here, when A is communicating with B, the C can also hear the signals from A. So in that case, it will restrain the transfer from C to D. Okay, because it will think that if it does, the collision can happen, but it actually does not happen. It's a misunderstanding of C. Okay, this problem is known as expose station problem. Okay, after having done about the data link layer, let's learn about the physical layer. Physical layer means the leastmost layer which is being used to transmit the data from one part to another part. Okay, in data link layer, in physical layer, there will be many types of connections which will depend on what type of data we want to transfer and what is the distance between the hosts. Okay, so there are mainly 5 types: 1, 2, 3, 4 and 5. Okay, in this we have 3 categories: FHSS, DSSS and infrared. Okay, so what happens is we will be using different modulation techniques in these both will be the same only, but we will be using different modulation technique. Okay, and in the last one, which is infrared, we will be using pulse point modulation. Okay, so let's see each one by one. See, in SSS and DSSS, we use the same baud rate, which is 2.4 to 4.8 gigahertz, and same data rate, which is 1 to 2 MB per second, but use different modulation technique. Okay, see here, we use FSK here and we use PSK here. This we discussed, I think, in back in module 2, right? So these are the modulation techniques we use in both of these. And the last one is infrared. In infrared, what happens is we use two sequences. The first one is 4-bit is mapped onto 16-bit, and second one is 2-bit is mapped to 4-bit. It depends on large data or small data. Okay, and we use a modulation called as pulse position modulation. Okay, and coming to the next one, which is OFDM, it uses a baud width of 5 gigahertz. Okay, and it uses PSK or QAM. So the data rate is also higher, which is 6 to 54. So let's see about that. Here it uses 5 gigahertz and 18 MB for PSK and 54 MB for QAM. Similarly, the next one is in the same way. The next one is DSSS, which uses PSK here, and it transfers the data up to 11 MB per second. Okay, so see here. Here we encode using 4 to 8 bits. See, there will be different encoding skips for each of these. Okay, like this was 4-bit and this is 4 to 8 bit and so on. Okay, and the data rate is given here, which is 1 to 5.5 or 11 MB per second. Okay, and the gigahertz has not changed. Like for transferring the more data, the gigahertz will also change, but here it is not changed. It is the same as the previous one, which is the normal DSS, which is 2.4 only. Okay, and the last one is OFDM, where we'll have 2.4 gigahertz only, but the data rate is very high, which is 54. Okay, so this is used for transferring very important data, and it's very high and it's very costly also. Okay, the baud rate is 2.4 and the data rate is 22 to 54 MB per second. Okay, and the modulation technique used is OFDM. Bluetooth we already know what it is. It's a connection between the various devices in a private network. So what happens is we cannot have two groups of Bluetooth connected with each other. Okay, means the connection will be there among the devices, but we can't connect these both groups. Okay, so that is one limitation of Bluetooth. Okay, it can have only private connections. AP cannot be used, and there are two types. First one is piconet and second one is scattered net. In piconet, the primary source will be there, which will be sharing the data to the other devices, and the second one is scatter net. In scatter net, we will have the primary source here, and the secondary will be connected, and one of the secondary can be primary also. Okay, so this will have further connections. This one is known as scatter net, and it uses short range radio transmitter using radio waves, and current data rate is 1 MB per second and 2.4 gigahertz. And like other networks, it will also have many layers here, like radio layer, the first layer, which is the physical layer, then the baseband layer, then L2 cap. Okay, let's discuss each one by one. In radio layer, the physical transmission happens. It can have a range of 10 meter, and it is 2.4 gigahertz. Okay, and it uses frequency hopping, means the frequency is frequently changed so that the error can be reduced. Okay, and coming to baseband layer, it uses TDMA, which is time division multiple access. It has the half duplex, so only one way to send on one way to receive. Okay, and it's equivalent to the next layer, which is data link layer. See here, we'll be dividing the time into multiple slots. In one slot, I will be sending this data, then the alternate data, then this one, then this one. This using the baseband layer. Then there are two types of connections, SCQ and ACL. In SCQ, it is used when speed is more important than the data transmission. Okay, if the data gets corrupted, that's also fine, but it should be transferred fast. If that's the priority, go for SCQ, which is synchronous connection oriented link. Okay, the another one is asynchronous connectionless link. In this, the data is more important. Even if it travels slowly to the destination, it's fine, but the data should be transmitted without any errors. Okay, that's the priority. And it has three types of frames: 1 slot, 3 slot, and frame 5 slot, which means 1 slot will be sent at a time. Here three slots will be sent, and here 5 slots will be sent. Okay, and coming to the frame format, it has three categories. Let's discuss each one by one. Access code is used to distinguish the new data set from the previous one. Header has the following subparts, which is address. Type means type of data, F means flow control, whether it's able to receive or send more frames, and A is the acknowledgement, and S is the sequence number, HEC is the header error correction. Okay, so this comes under the topic header. Then coming to payload, payload is nothing but the data to be sent. The last one is L2 cap. It's the similar to the logical layer of the normal transmission of the data, which we learned: physical layer, data link layer, and the network layer. So data link layer has this one, L2 cap. In this, there are three types for the format. Length specifies the size of the data, channel ID is unique for each channel, and data control will have the data and the control commands. Telephony is the network between two moving devices. What are the moving devices? The mobile phones. Okay, so mobile phones can be shifted from one place to another, and they should be connected to a network. Okay, so for that we'll be using cellular telephony. They could be between two moving devices known as mobile stations. So the mobile will each mobile will have a mobile station. Okay, there can be a communication between a mobile station and a landline. See, mobile can be moved from one place to another, but landline will be fixed at one place, right? So you can have a connection between these both. Okay, this is called a land unit. And if the cell is to be transferred to a base station, new base station, when it goes out of the range, suppose that you are moving in a car. Okay, see here, this one base station, this one base station. If you are moving in a car from this one to this one, the range of this one is this much only. When you go out of this range, at that time you should be connected to the new base station, right? So that will be happening from one base station to other base station while moving. Okay, so the basic procedure as follows: when you make a phone call, at that time public switch telephone network will get the call, and they will forward the call to the respective mobile switching center, and they will find the particular cell in which the mobile phone which it's trying to connect is present. When it's transferred there, it will transfer the call to the base station, and that will find the particular mobile. Okay, for each base station there will be many mobiles registered. This is known as a cell. Okay, there will be many cells, each will have a base station. Okay, and what is the frequency reuse? See, there are limited amount of frequencies, so what we have to do is we have to reuse the frequencies. If you reuse 4 frequencies, its factor is 4. If you reuse 7 frequencies, its factor is 7. Okay, in that way we will be reusing the frequencies. But the thing is, if the frequency of type 1, it should not have any frequency of type 1 adjacent to it. Okay, so we will be using a different combinations at each point. Okay, and transmitting means when you make a call, it will forward to a mobile station that will find the particular cell through which it belongs, then cell will transfer the call to the mobile station's network which the mobile is trying to call, and that will forward the call to the main phone. Okay, this is the transmitting procedure. And handoff and roaming is nothing but handoff is for local use and roaming is for worldwide use. In handoff, what happens is if you travel from one station to other station, as discussed before, the line will be broken from here, it will be made from here. Okay, if this happens in this way, it's known as handoff. What's roaming? Roaming is the same thing, but it happens between different countries. Okay, if you're traveling from one country to another country, the same base station will be made a contact with the other base station of other country. Okay, so that when the phone moves from one place to other place, the connection will be made with this base station, but will be having the server of this station only. Okay, so under this topic there are four generations of mobile networks. So let's discuss one by one. The first generation was used for voice communication using analog signals. Okay, so one of the company which is American based is AMPS, Advanced Mobile Phone System. It used 1G network. Okay, what happens there is it uses 800 megahertz band, and there are two types, two channels are there, one for forward and another for reverse. What is forward? When you make a call to other device, at that time first the call gets transferred to the base station, that is forward, and from the base station to the mobile phone which the call comes, that is the reverse. Okay, so the forward is from base to the mobile, and the reverse is from mobile to the base. After knowing about these two channels, let's see about the type of transmission. It uses FDMA. FDMA means frequency division multiple access. Okay, what happens is there are many calls being made simultaneously, so each of these calls will be allocated to a particular bandwidth. Okay, and then they will be transferred. And coming to second generation, the same thing, everything is same, but the only difference is we'll be using a digitized AMP. Okay, for that we'll be using a digitizer which will allocate into a different time slots, and here we are using TDMA. Okay, and then FDMA, both things we are using, but first we are using TDMA. What this does is it will allocate different frames to each of the slot. Here means 1 2 3 is a frame, and the same frame is repeated at specific intervals of time. Okay, and then we are combining this and sending through a main channel. Okay, and there were two companies which were made. First one is GSM, which was having two duplex bands. In that, what we do is instead of sending the one frame here, means this frame directly we are sending, instead of that what we did is in that we made this as a single point, and like that many points will be there, means each of this will be having a multiple frame. Okay, and this will be sent through a main channel. So here the bandwidth will be more. Okay, because each of this frame is getting combined and then it is getting sent. Okay, so the combined frequency will be more here, and it will be more efficient also. Okay, and the next one is IS95, which is interim standard 95. This is another type of baseband where we will be not using the time division, instead we will be using code division multiple access. Okay, it's the same thing here. It operates at 800 to 1900 megahertz, and it's divided into 20 channels. Okay, so here are the 20 channels. What we'll be doing is, firstly we'll be using a digitizer to make the main signal, and after that we'll be using some tools to remove the errors and all, and then we'll be combining it with the other channels, and then we'll be transmitting it using FDMA. Okay, and there are two things, the forward and the reverse transmission is same, the diagram is same, but only the difference is in forward we'll be using CDMA, and in the reverse we'll be using DSSS. Okay, third generation, it uses a combination of technologies of digital data and voice communication. Okay, so the internet is enabled here. In the second generation, first generation, internet was not there and digital data was not there. Okay, and the voice quality is comparable to, means it's similar to the existing telephone network, and it uses a band of 2 gigahertz and a bandwidth of 2 megahertz, and depending on the various applications we'll be using different types of modulation techniques. Okay, and coming to the current generation, which is the fourth generation, it's a spectrally efficient system and its high network capacity. The data rate can vary from 100 Mbps to 1 Gbps, and it's smooth handoff. Smooth handoff means while transferring from one network to another, means if this is the base station here, this is another base station, if you have moved out of this range, at that time what will happen is the connection will not break suddenly. When this connection is successfully made, at that time this will be broken. Okay, that is smooth handoff, and it is seamless connectivity, means it's globally used very efficiently, and it has better multicast security and optimization, and it uses IPv6. Okay, and for access it mainly uses two schemes, FDMA and CDMA schemes, and for modulation it uses QAM. Okay, and the radio components which were used in the 2G and 1G were hardware components, whereas in this one it is software defined radio system. Okay, and one more thing, and it supports multiple input multiple output operation. Okay, means it's not like it will wait for one single output input to be processed, then it will take the next output. Okay, it will be having parallel transmissions. Okay, so they will be having multiple channels for the parallel transmission and parallel processing. Okay, so it's widely used in the day-to-day life.